So in this lecture, we are going to discuss about the projectile. So here we have the definition of projectile. Any object that is thrown into space with some velocity, and that velocity has to make some angle with the horizontal, then it is said to be a projectile. And the path that the projectile traces is called its a trajectory. It can be proved that the trajectory, the path that the projectile is going to trace will be parabolic. Will be what? It will be parabolic. We can prove this. We'll take up the proof in the next section, but let us first get into the analysis of what we have to do in a projectile motion. So let me draw the diagram. There's a body which is being projected with a velocity u at an angle theta with the horizontal. So it is going to follow what path? It is going to follow a parabolic path. Now, how do we analyze a projectile motion? So there are some steps that you need to follow. So if I say projectile motion, and whenever we are seeing a velocity vector, whenever we see a vector inclined, what we have to do? We have to resolve them. We have to compulsorily resolve. So let us try to resolve this u first. So u is going to have two components, one along the horizontal and one along the vertical. This is the initial velocity along the x-axis, which is u cos theta. And this is the initial velocity along the y-axis, which is going to be u sine theta. So there are some steps which you need to follow for projectile motion. First, you have to resolve the velocity vector. Step one will always be to resolve the velocity vector and note down the acceleration. Make a note of all the accelerations acting, so that based on the acceleration, we can decide the type of motion. So in projectile motion, step one is to resolve the initial velocity, and note down the accelerations. Note down the accelerations. Here, which is the only acceleration acting? Only gravity is acting, isn't it? Only gravity will be there. Only acceleration due to gravity will be there, and that is purely along the y-axis. So if I have to break a projectile motion, because I have already resolved the velocity along x and y, we are not going to analyze the projectile as a whole. We are going to break up the projectile motion into x-axis and y-axis and analyze separately the x analysis and the y analysis. What will happen along the x-axis, we will find out separately. What is going to happen along the y-axis, we will find it. So projectile motion, if I break up along the x-axis and if I break up along the y-axis. Now, what is there along the x-axis? As I told you, resolve the velocity and note down the acceleration. Acceleration is there only along the y-axis. Acceleration along the y-axis is equal to g, and since acceleration is a vector quantity, it's in the downward direction, so I'll write it as minus g. And is there any acceleration along the x-axis? There is no acceleration, and acceleration is not inclined also, so that I can resolve and get the x and y component. Acceleration is purely along the y-axis, so there is no acceleration component along the x-axis. So x-axis acceleration is 0, very important. And acceleration along the y-axis is minus g. Minus just indicates downward, and g is a constant value. Acceleration equal to g. G is how much approximately? 10 meters per second square. And that's a constant value. So when acceleration is 0, what kind of a motion exists along the x-axis? When acceleration is 0, this implies velocity is constant. Velocity is constant along the x-axis. So along the x-axis, velocity is going to be constant, and such a motion is said to be what? Such a motion is said to be uniform motion. What motion is this? Uniform motion. Very important. So along the x-axis, acceleration is 0, so velocity will be constant, and that motion is said to be uniform motion. And we know when velocity is constant, we have only one equation that is applicable. So the equation that is applicable is velocity equal to displacement by time. This is the only equation applicable. When acceleration is equal to 0, this is the only equation applicable, we know, which we have studied in motion in a straight line. And when acceleration is constant, when acceleration is a constant value, acceleration equal to minus g, and that is a constant value, isn't it? Minus 10 meters per second square. So that means acceleration is constant. When acceleration is constant, what motion it is said to be? It is said to be uniformly accelerated motion. What motion? Uniformly accelerated motion. Along the x-axis, velocity is constant, but along the y-axis, what is constant? Acceleration is constant. So when acceleration is constant, what do we apply? We apply those kinematic equations. What equations do we apply? We apply those kinematic equations. What are the kinematic equations? The kinematic equations are v equal to u plus at, s equal to ut plus half at square, s is equal to u plus v by 2 into t, v squared equal to u square plus 2as, and then displacement in the nth second is u plus a by 2 into 2n minus 1. So we saw this in motion in a straight line, that these equations had to be applied when acceleration was constant, and this equation had to be applied when velocity was constant. Now, when I analyze a projectile motion, I see that there is no acceleration along the x-axis, so velocity is constant. And when velocity is constant, the motion is said to be uniform. And the only equation applicable is velocity equal to displacement by time. And along the y-axis, acceleration is a constant value. Minus just indicate the direction is downward. The value is minus 10 meters per second square approximately. So therefore, acceleration is constant along the y-axis. Therefore, we can apply all those kinematic equations. Are you all following? So these are the equations that those are applicable here. Clear? And then the next thing, very important thing is, how do you find the direction of velocity? How do you find the direction of velocity? Let us take up in the next sheet. There are some important points which everyone should understand. We know that the slope of displacement time curve. We know that the slope of displacement time curve will give us what? Will give us velocity. And how do we find the velocity? How do we find the slope? Velocity, how do we find? We need to find slope. And how do we find the slope to the curve? It is obtained by drawing a tangent to the curve. I'm checking out how much angle it makes with the x-axis, isn't it? Slope is obtained. How is slope obtained? By drawing a tangent. By drawing a tangent to the curve and checking out how much angle it makes with the x-axis, and tangent of that angle will give you the slope. And slope is giving us velocity, isn't it? Therefore, what I will do is, suppose, for example, if the body is at this point, how do I find the direction of velocity? How do I find velocity? By drawing a tangent. So how do you get the direction of velocity? By drawing a tangent to the curve that represents the direction of velocity, v. V is the velocity at any instant. And how much angle V will make with the horizontal? V will make some angle, let us say alpha. We will make some angle, let us say alpha. Again, I can resolve this into two components. Whenever I have a vector inclined, my work will always be to resolve. So if this is V, this is alpha. So this component is Vx, isn't it? And that is equal to V cos alpha, velocity along the x-axis. And this will have velocity component along the y-axis, which is nothing but V sine alpha, isn't it? Same thing I can do for initial velocity also. I can resolve it into two components, one along the x-axis and one along the y-axis. So this component is going to be u cos theta, which is initial velocity along the x-axis. And this is nothing but the initial velocity along the y-axis, which is u sine theta. So we understood one point, that the slope of the displacement time curve will represent velocity. Therefore, if I want to find the direction of velocity, I have to draw a tangent, isn't it? Okay, then next, this v cos alpha, I can tell that this is going to be equal to u cos theta. What is the reason? V cos alpha will be equal to u cos theta. What is the reason? Because we saw that along the x-axis, acceleration was how much? Acceleration was 0. Along the x-axis, acceleration was 0. So velocity is constant along the x-axis. So what was the initial velocity along the x-axis, people? It was u cos theta. So it is going to be u cos theta throughout. Along the x-axis, velocity will be equal to u cos theta, isn't it? It is going to be equal to u cos theta. And along the y-axis, acceleration is equal to minus g, isn't it? Acceleration is minus g. Acceleration is constant, not velocity, isn't it? Acceleration is constant, not velocity. So v sine alpha, I'll write it here only, that this is not equal to u sine theta, because along the y-axis there is acceleration. So velocity will keep changing, but along the x-axis, velocity is constant. Then the important point is at the highest point, velocity at the highest point. This is a very important point. Velocity at the highest point. What will be the velocity at the highest point? See, we should not immediately tell velocity is 0. So that was motion in a straight line. If you remember, if you recall, we had a body which was thrown with a velocity u in motion in a straight line chapter, motion under gravity. So the body was rising, correct? It reaches to maximum height and then it falls back, isn't it? It falls back. At the maximum height, velocity was 0. Here you see that this is motion only along y-axis. This motion, no, which is there, it is only along y-axis. Motion exists only along y-axis. But here in projectile motion, there is a velocity along x-axis as well as y-axis. But here u is only along y-axis. So this is motion only along y-axis. So velocity was equal to 0 at the highest point. Here you should not tell immediately that velocity is 0 because a two velocity exists at every point. One is the x component and one is the y component. First you draw a tangent here because by drawing a tangent to the curve, that will tell you the slope, isn't it? And slope will give us the velocity. So how do you find the direction of velocity? By drawing a tangent. So draw a tangent simply, correct, that will represent the direction of velocity. And at the highest point, tangent is purely horizontal. How does the tangent look, people? Tangent is purely horizontal, and we know horizontal component is going to remain the same. How much is the horizontal component? U cos theta. Horizontal component velocity is going to be same because acceleration is 0. So velocity will be u cos theta. Then what is 0? Because the tangent is purely horizontal, the vertical component is 0, isn't it? Tangent is purely horizontal. Purely horizontal. There is no vertical component at all. Therefore, what is 0 is velocity along the y-axis is 0 at the highest point. You have to specify two things very much clearly, isn't it? You should not tell velocity at the highest point is 0 immediately. Velocity at the highest point is 0 along the y-axis because tangent is purely horizontal, correct? But the velocity along the x-axis is still existing, that is u cos theta, isn't it? This is one point. Then another point, suppose for example, if we are neglecting the air resistance, that is we are not considering the energy losses here. So we are considering that energy is not lost during the process when the projectile is fired from the ground. There is no air resistance. So if you are throwing with speed u, correct? If you draw a horizontal line here, the body will strike the ground with the same speed u, but direction will reverse, isn't it? We know this from motion in a straight line. If you're projecting the body with speed u, it will strike the ground with the same speed u, but direction will reverse. Let us say here the speed of the body is, say, let us say to be, say, some 3 meters per second. Here also you draw a horizontal line. Here also it is going to be 3 meters per second, but in the downward direction minus 3 meters per second. So here, if it is v cos v here, if the velocity is v, then you draw a horizontal line here. Here also velocity will be v only, but direction will change, isn't it? So body is coming down here. So you draw tangent. Tangent is going to be like this. So this is my v. So v is making how much angle with the horizontal? Alpha. So again, I'll have two components for v. One is v cos alpha, and then one more is what? V sin alpha. So velocity, you draw horizontal line, velocity is going to be the same. And here it is how much? Here it is u, isn't it? So here you draw a horizontal line here. So if you're projecting the body with the speed u, it will strike the ground with the same speed u, correct? But directions will reverse. So you just draw a component for this u, one along horizontal and one along the vertical. So theta was the angle made by u with the horizontal. So this is u and this is horizontal. So this is theta. So this is going to be u cos theta and this is going to be u sin theta. Is it clear? And what is the velocity at the highest point? Velocity at the highest point is equal to u cos theta. The y component is 0.